one more second case. Okay, we have this is source S1, S2, S3, S4. Okay, if they have some initial phase, so this is for my convenient purpose, I'm writing having a phase phi, this having 0, and let this be 0 phase. Some initial phase with that one. So nearby that I'm writing that one. So what are this? These are the two identical sources. So the wavelength, the radius of this be lambda. This one, and let lambda be the wavelength of the wave. So let me describe the question. What is the question? Four identical coherent sources of wavelength lambda and having initial phase as shown. They generate a sound waves. Huh? These are coherent sound sources. Alright. Somebody is asking, sir, what are these sources? Sound sources, sound chapter it is. So of wavelength lambda and having initial phase as shown. Okay, the initial phase is what I'm giving, phi 0. So this will be 0 phase. This will be phase angle pi by 2. There's a description of the problem. Let me assume let I not be the intensity at point P individually due to each source. Okay, this one. So again we'll make it a condition. Some initial phase I brought it. So both will cover, all will have same path, but they have initial phase. So what conditions will come? S1, resultant intensity at point P. So when off, you can go for several combinations. I think these four are enough for us. When all are switched off, no sound wave. When both are switched on, tell me what will happen. They are coherent. Strictly they are coherent. S1, S2, S3, S4, they're coherent. There's no problem with this. Tell me in this case what you do. Will you write 4 I naught? No, you look at, there's the initial phase is there. So what is it now? First case, there's A, B, C, D. For case B, what happened? Let me discuss the problem. Can I continue? Can I continue?
Yes, sir.
Okay, this power, I don't know, it is troubling a lot. What shall I write? Path difference of the waves. This will cover a path lambda. This will cover a path lambda. Is it okay? You can see this. I'm writing how much of path length it will move. So what is the like a phase difference due to path will be 0. Okay, I got this as pi. Tell me, like, will it be constructive or destructive interference? Who will answer? So how do you can say constructive, destructive? Okay, let's do one thing. If the phase angle is equal to pi, if the phase angle is equal to pi, go back to the theory what we had brought here. Come for this. Put n equal to 1, how much you'll get? Pi. Put n equal to 2, put n equal to 2, 3 pi. Here what are the things? You see 0, 2 pi, 4 pi, 6 pi, 8 pi. Okay, no? Or n will be like this. So this will be even phase, no? 2n pi will be. This will be odd, like it will be put n equal to 1, 2 minus 1 pi, pi, 3 pi. If the phase difference between two waves is pi, 3 pi, 5 pi, 7 pi, 9 pi, it will be destructive interference. If the phase difference between two waves is 0, 2 pi, 4 pi, 6 pi, 8 pi, it will be constructive interference. So what you suggest now? Will it be constructive or destructive interference? Will be destructive. So still we are not that good in maths. Okay, no problem. You at least you can you write this? Anybody can write. So what is delta x equal to now? Lambda by 2. If the path difference is lambda by 2, so like if the I think I'll be troubling you if you write it up, because the path difference is 0. Again, you are writing, sir, from where this has come. So therefore, this is a wrong. Just I mean to say, explain. If delta x equal to lambda by 2, constructive or destructive? It should be destructive. So therefore, if the phase difference between waves is pi, 3 pi, 5 pi, 7 pi, it should be destructive interference. Don't write again this. It's the wrong thing. To explain, I just brought it here. So take out this one. So the net phase difference is how much here? 2 pi. So therefore, the waves from S1 and S2 undergo destructive interference at center of circle P. This is the idea. So because of this, what should be the intensity at point P? Will be 0. Got the idea? This one? Now, what you write here? Anybody? Due to this will be 0, no? Only due to this it will come. It will be only I naught. Because the waves arriving at point P due to this two will cancel out. The intensity due to this will cancel. Only due to this it will be there. Only due to this is how much? I naught. Okay, so like we are not understanding. Okay, you're not understanding. So we'll do one thing for C. We'll show mathematically. The net phase difference will be due to E path, no? So this should be equal to how much it will be. Due to this will be pi. I think I'll do one thing. I will show the phasor diagram. This will be much easier for you. What is the phase of this wave? It was a pi, no? By the time it covers a distance lambda, how much of phase it will attain? 2 pi. 2 pi. I'm coming to actual discussion now. When delta x equal to lambda, shall I say 2 pi? Already it was having a phase pi. By the time it arrives here, how much it will become? Pi plus 2 pi, 3 pi. So 3 pi, how you represent? So this will be 0. This will be pi. 0, pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, and 3 pi. Am I right? Mathematics, take help of mathematics. Mathematics is not solving something. You should should apply here. So phase of this is 0 degrees. So 0, pi by 2, pi, 3 pi by 2. Then next what you write? 2 pi, 5 pi by 2. Then this will be 3 pi, no? Then this will become 7 pi by 2. Then this will become how much? 4 pi. Are you able to rotate? So as I rotate now, 0, pi by 2, pi, 3 pi by 2, 2 pi. Then 5 pi by 2, 3 pi, 7 pi by 2, then 4 pi. Okay, now 3 pi, how you represent? 3 pi you are going to represent. So this is for your convenient. I'm showing the first problem. No, I'm showing that mathematics, or else in SHM long back you have come across. Okay, now let's draw one more. So according to that, 3 pi, where I should represent 3 pi should be here, no? The first one, there's a 3 pi. Then next, what was the phase of this 0? By the time it arrives here, how much of phase it will gain? 2 pi, no? Because of this formula, delta x equal to lambda 2 pi. 2 pi means I should put like this only. So this is due to source 1. So due to source S3. So how much of phase it will have? Pi by 2 plus 2 pi. 5 pi by 2. 5 pi by 2 means where I should represent. Okay, it should be here only. The arrow you can see now. This is due to what? S3. All are having same amplitude, A. So what is the resultant intensity should be? The resultant amplitude should be A minus A. In the vector form, no, the resultant amplitude will be only A. This will cancel, no? Plus A minus A, resultant will is A. I'll square this. Because I naught is proportional to A square. That's what, no? This is what? IR equal to IP. Are you able to understand now? Now the initial phase comes, you should take help of, and when more than one wave comes, no, it's better to take first calculate amplitude, then resultant intensity. This is for C. For C, what happened? This is what happened. So what is the intensity here? Will be only I naught. I agree this. How it is I naught? This one. Okay, let's come for when all are switched on. Already we have discussion, no, here. So due to this will come. What is the phase of this? Will become 2 pi, no? So shall I add up? Shall bring a S4 here. So the phasor diagram. Let me end up in this page only. I naught proportional to A square. Okay, got the idea? More than 2 sources, what you should do? You should take help of the phasor diagram. Okay, this was the here only. I have. I think I'll. So this will be due to S3, S4, S2, S4, and this is S1, and all are having amplitude E. What is the resultant intensity at point P now? First, resultant amplitude will take it. Anybody resultant amplitude? You should be very good in this one. 4 vectors are there. Root 2A. I'll square it. IR is equal to, this will be 2A square or 2 I naught. Got the idea now? So if the initial phase comes, no, you can't write 16 I naught. If there is no initial phase, If the phase difference, this is pi by 2. No, if all are having zero phase, in that case, will become how much? 16 I naught, 4 I naught it will become. You can see here. There's the beauty of this but such numericals. Even the initial phase also matters. Most of the problems, initial phase difference will be zero. If they give initial phase, so you have to be careful. I'll take you back. Can you remember if the what is the initial phase of all them will be zero? It is better to, if I write zero, you'll get confused with a point two. So initial phase difference is zero. If they're having any initial phase, that this what condition arises. Any doubt? If you have, you can clarify it. Any doubt? See, if you just open book, no, you have intensity. Okay, that formulas, that one. But the background is needed. Huh? A student has to be very careful about the conditions. What is AR? Resultant amplitude. Okay, fine. This is about the initial phase, the path difference, everything. Okay, let me trouble you further. If if the sources are incoherent, what you're going to write? Note. Let me put here. If all four sources if all sources are incoherent, so what is the resultant intensity at point P? Anybody wants to answer? Has to just add up intensity due to individual source. I naught, I naught, I naught, I naught. For I naught. Getting the idea? This one? Just add up due to all. No, if they are incoherent. If all four sources are incoherent, there is also initial phase. Tell me how what you're going to take a decision. Think on it. I'll bring some space to scribble. Not possible. Anybody? If all are incoherent, any change in the answer? I'm not getting any reply. This is our discussion note. If all four sources are incoherent, then what will happen to resultant intensity? But sir, there's an initial phase. That doesn't matter, sir. This initial phase doesn't matter. Are you getting the idea? This initial phase also doesn't matter. So you are going to just add up. I'll put note. Huh? So when you are discussing constructive district inference, what you have to keep in mind? How many sources are there? 2, 3, or 2 sources or more than 2 sources? 2 sources, we have a formula. More than 2 sources. So what you should do? You should calculate the phase of a wave, phase of a individual wave arriving at that one. You can see, sir, how you are putting these phases here. What is the phase of this initial phase pi? By the time it arrives here, how much will become due to path length lambda 2 pi plus pi? What is the phase of the wave arriving at point P? Wave 1 will be 3 pi. So when you get a more than 2 sources, so what you should do? Calculate the phase of individual wave at a point where you are discussing, where you are finding out the resultant intensity. Draw the phasor diagram, represent them here like this. Then after getting this, what you should do, calculate the resultant amplitude. It's a vector superposition, like a resolution of vectors idea. Calculate the resultant amplitude, square it, then get the resultant intensity. Got the idea? If only two sources, quite very simple. No? The formulas we have, these formulas. So this entire problem, what you should do, two sources or more than two sources, the numerical is. Anybody I have a doubt? If you have a doubt, please do clarify. If you have a doubt, please do clarify. I'll discuss, I'll get into the numericals application part. The same thing we are going to discuss YDSC for 1 week. We are going to discuss the same interference of light waves. Here interference of sound waves we took it. Then interference of light waves we are going to take it. Okay, now let me ask you some very general things because now, okay, all of you, now we have a television system, left speaker, right speaker. I think some of you are having even home theater also in your home. You'll be having some woofers that were no some 4 or 5 speakers all together will be there in your home. So each speaker, shall I say, it's like a source of sound. What we are writing S1, S2. Then let's take help of television. I'm going to take help of the same discussion because there's a, at least you should have asked this question. You are not asking, so I'll ask. So we have a television set.